Welcome to this first lesson in the Programming for Actuaries course. This is just a short video just to guide you through the main topics that we'll be going through. The format of the course is that there'll be a video at the start of each lesson which you can go through. This will give you an overview of the files and data files you'll be using. This lesson we want to talk about how to get R set up on your system. And then we'll also look at how to load the data files into R. And then we'll finish off by looking at the different data structures in R. So firstly, let's just talk about the key topics here. So in terms of loading data into R, we will cover how to load CSV and text files. We'll cover reading Excel files as well. And we'll also talk about how you can load large data sets, as well as a discussion on packages. So why R? The main benefits of using R for actuarial work is that R allows you to efficiently import and transform datasets, especially CSV or text files. R can connect to databases, so it's a really efficient way of working with data, and typical actuarial datasets usually consist of lots of data, lots of rows, lots of columns, and R is used in a lot of companies to run different processes, typically things like capital modeling or IFRS 17 or any sort of data intensive workloads. So in this course, we'll be learning how to use R, and the objective is to make sure that you can apply R in your actuarial work. So the first thing, if you haven't installed it, I've got some instructions here on how to install it. It should be pretty straightforward to install on your system. Just follow the instructions on this page. And then once you've installed it and you've opened it, you should get a window which looks something like this. So just to talk you through the different areas, so this box on the top left, this is usually where you write most of your code or your scripts, which I'll describe. And then down here where it says console, this is where you usually see your output. And then on the right here, there are boxes where you can see data objects like tables. And then the window on the bottom right is for navigating in different folders. So the first thing I'll recommend when you're working in R is to organize your work into projects. So setting up a project is quite straightforward. You just follow these instructions. You go to File. If you click the File button and you just say New Project, then it will bring in these boxes, and then you can select which directory you want to keep it in and give it a name. And once you do that, R will create an isolated directory where you can keep all your files and folders in one place. That is quite useful, especially when you're working on different projects where you don't want your packages or your code and data files to be mixed up. It's also useful when you start trying to version your work. So yeah, I highly recommend you follow these instructions and you create a specific project. Once you have a project, if you look on the right, bottom right here, you'll see that you have this file called proj with a .proj extension, and effectively, if you navigate to that folder and you double click that, it'll just open your project, and you'll be able to see all your work and where you last saved it. So yeah, so go through this, follow these instructions, and just see how to work with projects. So the first thing we're going to do is to read data files into Excel. So typically you want to read text files or CSVs or Excel files. So starting with CSV, there's a inbuilt function in R which is called read.csv, and to run it you just specify the file, you've got different options that you can specify. For example, the separator, it might be tab or comma or hash. There's different type of um, separators here. There's different options, and you can see all these options. If you were to highlight that function read CSV, if I press F1, if you look on the right, you'll see that it gives you information on all the, I guess, the parameters that you can use, and a lot of these arguments are optional. So, for example, specify the file. There's a description of um, what each parameter means. So let's do that. So if we go back uh, to our data in our home directory in this project, you should find a file called lab.csv. That's just a CSV file with different variables. The data set that we'll use quite a lot in this course. Um, so we're going to use that function. So if you run this code here, what this will do is it will just read that file, and basically you can see we haven't added any optional arguments. That means I will just load that file using default arguments. And this should work for a lot of your cases. If you have a CSV file that is structured in a standard way, so for example, I will automatically look at the top row and set that as header, and then you've got all your data loaded in R. Um, so one of the things you might want to do is once you've got your data, you want to see that data or see different information about that data. So for example, if you put this function called head and with with 10, it basically goes in and brings out the first 10 rows. You can also see sort of the different variable types. So you've got integers, you've got factors, and you've got some characters. So what we can do is sometimes you might want to summarize like information about your data. So if you pass this function there, what you'll see is that if I scroll to the output here, you can see it's a summary of all your variables and the variable types. So that's quite useful to just get a quick view of the data contained in your dataset. And then what you can also have a look at is if I go to the next, um, sometimes you want to look at specific variables. So for example, uh, if you want to see what variable type each variable is, for example, there's a variable called duration, and if you want to see what type it is, it tells you that it's an integer. Uh, it's very important to understand how R has interpreted your variables. As we will see later, sometimes you might load data with some text and the characters. R might think it's just the character string, but actually the data might actually be certain categories. So you might want to convert that into factors. The next thing which is important to note is that some of your data will have rows where you don't want to import. So as a classic example, some text files, they will typically have sort of a row which is empty, or in this case, you've got the first two rows that you want to ignore, and there's an argument there to just tell R to skip the first two lines. So in this data set, if we try and load it in, effectively you'll see that there's a. Let me just check that we've got that folder. So we R has just thrown up an error in the load. So what could cause this? So effectively, we just need to check if this file has been loaded. So if we go to your home directory again, so in the home directory, if you click on the right there and select go to home directory, you'll be able to see all the files that you need. So you can see that we don't have the file in this home directory. So what we're going to do is we're going to change the home directory. Uh, and the way we do it is if we click this button there, you can actually browse to the directory where you want to go to. So if I click that, so now I'm in the directory and I can just say set as working directory. And now you can see the file we actually needed. Let's just look at the name. That's the file we need. And you can see it is there. So if we now run this, we should be able to work. So what I've just shown is quite a typical thing when you try and load files. You will see some code where, for some reason, people change the working directories and that can break your code. So just remember to always uh, know where your home directory is and to be able to see that you can just type in this code. So get working directory just tells you where your home directory is. So now that we've loaded the file, we can look at what we want to do. So for example, this file has quite a lot of variables. This is actually a typical sort of model policy data file that you might see in actuarial work. Sometimes you want to just load specific variables. So instead of loading everything, if I run this code, I'm going to tell it these square brackets on the right just said load the file, but just give me the specific variables I want. So it's created this object on the left. That's what you see there. If we double click it there, you can see this. It's got the variables that we want. So that's the basic of loading a CSV file. So if we want to do more with our data, we need to start using packages. So effectively, you can think of packages as inbuilt R functions that are designed to either streamline, standardize, or optimize common tasks. So while you might write a piece of complicated R code that does something specific, there might be a specific package that simplifies it. So yeah, list the advantages of using packages. You can go through that in the material. In order to install a package, you just type in that code. So you say install packages and the name of the package, and then run it. I've actually already installed these packages. But once you've installed it, you have to load it. So every time you start a session, you need to load the packages you want. So for example, if I run this code, what it's going to do is going to load the packages that you need, and it gives you some messages to tell you that it's loaded the packages. A useful way is if you want to understand what a package does, just put a question mark in front of the package name and run it. And what that does on the right is you'll be able to see down here all the help and description about that package. There's other sort of help functions that I've listed there, which are useful to understand how a package works. So just to show you the power of packages, what we're going to do here is we're going to load the data set using two different methods. The first one is using um, the sort of this, a new package called fread, and this is a package from the data table package that we've loaded. And the second one is just the same standard read CSV file. And what this code does, it first records the start and end time, and then it does a piece of code, and then this should return how many seconds it took to load. So it's the same file. If I run the first one, it says it took 0.3 seconds to load that file in. But if I run the second one, uh, still running, that took 10 times longer. Right, so both packages do the same thing. One is quicker, one is optimized for loading large files. And this is just an example of why packages are important, because it allows you to use the most efficient tool for your work. Let's talk about reading Excel files. So in this example, we're going to read an Excel file, and the file we want to read is basically it's a large Excel file, but we only want to take data from a certain range. The first thing we'll do is we'll load the libraries we need. So we'll need the tidyverse, and we also need this package called the read Excel. Uh, and now what we'll do is there's a what we're going to load is a spreadsheet which is called home insurance. So just to show you what that spreadsheet looks like, if we go into this folder with our data, you can see it's a spreadsheet with different columns. It's got sections that have different sort of data. We might not be interested in all this data. We might be interested in a specific range. Um, so say, for example, we only want to load the range A3 to B32. So that's effectively just this table. In R, you just write this command read Excel, the name of the file, and you tell it what sheet, and you also tell it the range. So you can see if I do that, R produces a file called data, and it's got the data that we had in the spreadsheet. So this is quite useful if there's a spreadsheet that you work with a lot. You can just write an R code to quickly extract the data, without having to open the file. So this is quite useful whenever you've got big spreadsheets that you don't want to physically open. Uh, let's just talk about data structures, because for the rest of the course we'll be working with data in different formats and different structures. Um, the most important data structure is a vector, and you can have effectively vectors of different types. The one restriction about the vector is that all the elements must have the same type. So here you've got numerical values, here you've got text values. So if I run this line, it's going to create three vectors, and with each of these vectors that is created, you can see them on the right. If it tells you what type it is, so I've also run this code down here. Just tell us the type of the vector, and you can see you've got a character and a double and numerical. We want to access specific variables within a vector. We use what's called subsetting. So for example, if that extracts the first element, that extracts the first three elements. So if I run that, you'll see that the first one took the first element, then the second one it took the first three elements, and then this one just took the last two elements with the minus sign. You can manipulate vectors in a lot of ways. So for example, in this one, you can add extra elements. So this is useful when you've got a vector that grows over time. You just write that code and just adds a new one. So typically like just adding a new record. Sometimes you want a list, and a list is really a structure which has effectively different elements. So here you've got a mixture of numeric and text. So a list can contain different elements which can be useful. So for example, you might want a list which has a name, age, hobbies. So in this example, you're sort of mixing different data types in one. Or you might just want to create a list which summarizes all your policy data. So in this case, I've got one object called policy data. And if you actually open it, you'll see that it's got information on different things. So it's got the premium data, it's got the gender data, and it's got the age data. You can then access certain elements of that list using these square brackets. For example, if you want to extract the gender vector element, you just put 2 there, and it'll bring that information out. Uh, this is what quite useful. This basically allows you to extract data for a particular person. So, for example, um, you can create a list which just extracts the first element or the first policyholder, and that assigns it to this variable called user data. And you can see you get information about that specific policy. So this is quite useful, especially when you want to combine all your information in one place. Um, is particularly when you have information that has different, maybe is stored on different tables, and you don't want to necessarily uh, join those tables together. You can just create a list that goes and extracts certain things about a particular record. Uh, let's talk about data frames. Data frames are probably the structure you'll be using a lot. These are sort of the familiar tables that you want. So, for example, here, if I just run this code, what if I create my data set here? You can see I now have a data set which has 3 columns. I've got my premium, gender, and age, it all formatted in a nice table. This is a sort of data structure you work with a lot. And you can see a data frame is really, you can just look at it as a collection of vectors. So in this case, it's just taken um, it's taken each of the vectors and just treated them as a column. Um, you can do quite a lot of things with the data frames. So, for example, you can extract certain columns using this dollar sign. So this just goes and extracts this particular column. Or you can use the names. So you can go and extract a smaller or a subset of that data frame, which only contains a subset of those columns. Or you can sort of use indexes as well. Um, you can create new columns quite easily by using this code. So here I'm creating a new column called monthly premium, which just takes my original premium and divided by 12. And if you look at the date sets, you'll see it's created an extra variable there. You can also do sort of typical selection or filtering. So in this case, you look at your data set and you want to filter rows where certain conditions are met. We'll talk about in the next lesson more advanced ways of doing this kind of thing, but just gives you a flavor of the sort of things you can do. You can combine data frames as well. So, for example, in here, I've got 2 files that I want to load. So I'm going to load 2 files, and these files have the same number of columns, but you can just combine them using this function called row bind. And effectively, what this will do is combine a larger file, which is a combination of the files you state. And you can see uh, on the right here that file is a lot bigger. So if I just run this, you can see the dimensions of this file. It's got 44,000 rows, whereas the files we added before had much less than that. So that's quite useful. Typically, you want to go look at, let's say, model outputs or policy data held in different files, and sometimes you might want to combine all of those files together. So that's why that can be useful. Uh, the other data frame functions that I'll leave you to investigate are listed below. So we've worked through this file, so we've saved this in the course folder. This should give you a good introduction on using R, and then in the next lesson we'll be talking about how to use that data to start doing more interesting programming on creating your own functions and running basic iterations in R.